In this video, we're going to see how to name and write formulas for compounds called hydrates. Hydrates are compounds that have water incorporated into their structures. So let's take a look over here, just as a quick example. Here we have something called cobalt fluoride tetrahydrate. You'll notice there's an ionic compound, cobalt fluoride, and then the word tetrahydrate after. What this means is that you have the ionic compound, cobalt fluoride, with 4 water molecules incorporated into the structure. Hydrate does not mean the same thing as dissolving. Sometimes you'll see a compound, let's just say like this. So you might have MgCl2AQ. What this means is that water molecules have separated the ions and have surrounded each of the ions, the magnesium and the chlorine, and that would be called dissolved magnesium chloride. So it's just magnesium chloride in a solution. But for a hydrate, you would usually see it written something like this. You'd have the regular ionic compound written out, and then afterwards you would have a dot. So it would be a dot, and following that dot would be the formula H2O, along with some big number in the front. So for example, 6. That big number would be called a coefficient, and it would basically tell you that the magnesium chloride has 6 water molecules incorporated within it. So this one here, magnesium chloride AQ, is simply magnesium chloride dissolved in water, whereas this one here is the hydrate. It's magnesium chloride with water incorporated into the magnesium chloride crystal. So this is called a hydrate, and the big number in front of the water, that's called a coefficient, and that basically just tells you how many water molecules are incorporated into that structure. So to name these types of compounds, you will have to remember the Greek prefixes. Essentially, when naming these compounds, what you do is you simply start off by naming the ionic compound. So we'll do that first. Here we have CuSO4. And so if you don't remember how to name ionic compounds with multivalent elements, go back and review the video and your notes to see how to do so. So here we have CuSO4, which is copper 2 sulfate. And we have 5 waters. So to represent the water, we write the word hydrate. To represent 5 waters, we use the Greek prefix that means 5. So we use the prefix penta over here, penta. So we put penta in front of hydrate. And so we have the compound, the hydrate, copper 2 sulfate, pentahydrate. We can try the one over here. Here we have iron 3 sulfate. It's a hydrate, so we use hydrate, and then we have to choose the proper prefix to put in front of the word hydrate. So there's 9. So the proper prefix for 9 would be nona hydrate. So that's how you would name hydrates. Simply name the ionic compound and then write hydrate and then put the proper prefix in the front. If you had 10, you would use the prefix deca. So here, for example, we have sodium carbonate, so sodium carbonate, hydrate, and we chose the prefix deca for 10, decahydrate. So notice you're not using the Greek prefix for the ionic compound itself. You're just using it to represent how many water molecules are attached to your compound. So let's do this example here together, the sodium perchlorate monohydrate. So the first thing you need to realize is that you have sodium perchlorate. Remember your derived polyatomic ions. So sodium is Na plus 1. And perchlorate would be ClO4. And the reason I know that is because regular chlorate was ClO3 minus. And so if the regular chlorate is ClO3 minus, I'm doing the per8 version, which is 1 oxygen above. So it's ClO4 minus. You don't change the charge, but you change the number of oxygens. So this is the perchlorate, and we had sodium, which is a charge of +1. When you do the crisscross or charge balancing, you end up with NaClO4. So this is our sodium perchlorate. And we have a hydrate, so we have to use our dot in between to show that there's water connected to it. And then we have H2O, and have to be bolded like that. And we have to take a look at how many H2Os we have. So since there's only the prefix mono in the front, that means there's one H2O, we can just leave it as is. So sodium perchlorate monohydrate. Let's try one where there's more than one water connected to it, see how it would work. So let's try lithium chloride tetrahydrate. Once again, you write down the formula for the ionic compound using the crisscross rule of the charge balancing. If you don't remember how to do that, please go and watch the videos for writing formulas for ionic compounds. So we have lithium chloride, and then we put our dot and our water. But you have to look carefully at how many waters you have. We have tetra. So tetra means 4. So we have lithium chloride tetrahydrate. So there's 4 waters connected to the lithium chloride crystals. And that's indicated by the prefix tetra over here. So again, we are using the Greek prefix in this case, but really just to represent how many water molecules are connected to the ionic compound itself. So you can try a few other examples. Basically, all the rules for naming ionic compounds still apply. You have to double check to make sure that you verify your charges for your multivalent elements. Don't use Greek prefixes for the ionic compound itself, but do use a Greek prefix for the water molecule. So we'll try one more together. We'll make a new one up. So let's have FeCO3, and we'll name this one. So we'll put our dot there and our 6 here. So I want you to try to name this one, then verify your answers with mine. So you can pause the video and then check your answers once you're done. So here we have FeCO3. So we know we have iron carbonate. Now remember that iron is one of those multivalent metals, so you have to figure out which iron you have. Is it 2 or 3? So to figure that out, you have to do the reverse crisscross. We have 1 over here. Put your CO3 in brackets, 1 over here. Circle the subscripts. The reason I'm putting 1 is because, well, there was no subscript, so it's an implied 1. Reverse crisscross, and you get Fe plus 1, the plus because it's a metal, CO3 minus 1. Make sure that this O is an uppercase O. If you put lowercase, it looks like a cobalt, so make sure it's an uppercase O. You double check the charge of your polyatomic ion. Carbonate should be -2, not -1. So that means this was reduced, so you have to unreduce it by multiplying everything by 2. Since it was 2 to begin with, it must have been divided by 2 if it's now 1. So when you do that, this becomes 2 over here. This becomes 2 over here. So in reality, you have iron 2 carbonate. Now, if you left it as is, you wouldn't get the full marks because you're forgetting that this is a hydrate. So you have to write down the name hexahydrate. And the reason I'm putting hexa is because 6. Hexa means 6. So hexahydrate. Don't put the dot in the name, only put the dot in the formula. Hexahydrate. I could have asked you to name this using the Latin method as well. So you could have said something like this. You could have said ferrous because it's the lower valence. Carbonate. Hexahydrate. And so that concludes our video for naming and writing formulas for hydrates. Again, use the Greek prefixes only for the amount of water that you're representing, and name the ionic compound just as you learned in previous videos. Pay attention to multivalent metals and polyatomic ions.